Friends, here is one more example on exact differential equation. It is solve y into e to the power x into y dx plus into bracket x into e raised to x into y plus 2y bracket into dy is equal to 0. So we need to solve this differential equation. For that purpose, we need to observe what type of equation is this. This is of type, already you know, this is m dx plus n into dy is equal to 0. So it is m dx plus n dy is equal to 0 type, where m and n are the functions of x and y. So now to check the condition for exactness, what we will do, we will differentiate a coefficient of x, that is coefficient of dx, that is m with respect to y. So we will consider m here. M is y into e to the power xy. Therefore differentiating partially m with respect to y, what we will get here? See, you observe here, this term also contains y, this term also contains y. So here are one is exponential term, another one is a polynomial term. So what you need to do, that is algebraic term. What we need to, you have to use u into v rule. So what we will do here, first we will keep e to the power xy constant here, then we will differentiate y with respect to y, which becomes 1. So e to the power xy into 1, it becomes 1. So we are directly writing, we can write this one as e to the power x into y plus now what we will do, y will held constant, y is held constant, then differentiating e raised to xy with respect to y. So what, differentiation of e raised to xy is e to the power xy. So once again differentiation of e to the power xy with respect to y becomes this is x, because whenever differentiating with respect to y, x is held constant, that is whenever differentiating partially with respect to y, x is held constant. Okay, therefore here also e to the power xy is present there, here also e to the power xy is present. So we can take common from e to the both the terms, e to the power xy. So you can write it as e to the power xy should be taken common outside. So from this term you left with 1, we can write it as 1. From this term you left with x into y, you can write it as e to the power xy into bracket 1 plus x into y. So this is dou m by dou. Now we will consider n. What is your n? N is x into e raised to xy plus 2y, which is given here, coefficient of dy. Therefore differentiating partially this with respect to x. Here you observe this term purely contains y term, so this is treated as a constant, so this becomes 0, nothing to worry about this. Now we need to concentrate on this term. So this term, both the terms here, again it is a polynomial in x, and e to the power you are having some terms in x here, so you need to use u into v rule here. So using u into v rule, differentiating partially with respect to x, what we will get, first we will keep e to the power xy constant, e to the power x into y constant, differentiating x with respect to x, it becomes 1. So you can write it as e to the power xy plus e to the power xy is held constant, x is held constant, e to the differentiation of e raised to xy with respect to x becomes e raised to xy into y, because when you differentiate this with respect to x, y is held constant, differentiation of x becomes 1. So it becomes e raised to xy into bracket 1 plus x into y. So you observe these two there, dou m by dou y, and dou n by dou x are one and the same. Therefore you can write it as dou m by dou y is equal to dou n by dou x. Hence the given differential equation, that is this given differential equation, is a exact differential equation. Therefore you can write the general solution as integration of what is that, m dx. What is your m? Y into e to the power xy into dx, where y is treated as constant, and here you can write a integration of, whenever you're integrating a coefficient of y, that is n, with respect to what care should be taken, you should take care that you should consider the only term without x. So this term contains x, which we are not going to consider. We need to integrate only this term, so that becomes integration of y into dy is equal to, this is integration of 0, it becomes a constant term, you can write it as a c. Therefore now on integrating, what you will get, see here, whenever you integrating this term with respect to x, y is held constant, you take that outside, you need to integrate only e to the power xy with respect to x. So integration of e to the power xy becomes e to the power xy divided by y, because this variable y is treated as a constant. Therefore with respect to this result, that is integration of e raised to ax with respect to x. How you are going to write this? This is integration of e raised to ax with respect to x. It can be written as e raised to ax divided by a. Here here y is treated as constant, so therefore you can write using with reference to this result, you can write this one as e to the power xy divided by plus. So 2 is a constant, you keep that as it is. Integration of y with respect to y becomes y square divided by 2 is equal to some constant. So what happens here? These two get cancels. This y get cancels. You can write it as a final result as e raised to xy plus y square is equal to c, which is the required solution of this exact or this given differential equation.